Hello, everybody. Hi, Michael.
Hey,
And
Alex.
hey, good morning, good evening, good afternoon, and thank you for joining Discovering Neo4j AuraDB free with Michael and Alexander. And today I have the topic already, so
Yep.
it's gonna be good. It's we talk about nicknames,
Yes.
and we have a special guest, I guess, with ChatGPT making an
Yep.
appearance. So
Exactly.
we we have
Exactly.
a special episode today. Neo4j, ChatGPT, or GPT LLMs, and Aura and Michael.
Yeah, exactly. So I think Alex and we chatted, and I think we wanted to do like a summer break for the live stream, and so we thought we wanted to do something fun for the last episode before the summer break. And actually, we had one of our colleagues was talking about entity disambiguation and entity reconciliation in customer data, right? So, for instance, if you have people called, Alexander and Alex and Lex and whatever
Yeah.
are the nicknames, Ali or so, right? So and they were talking about that usually for consolidation of, like, if you mistype something or misspell something, you can do something like, how many characters do I need to change to get from A to B, right? So
Yeah.
for instance, if someone said Michael and they forgot like an E or an A or something like that, then that's like one added distance away from Michael, right? So you could say basically, okay, that's one way of how I can kind of figure out how kind of names and first and last names go together.
Mm.
But then they brought up, but what we do we do with all the nicknames that people give folks, right? So if someone is called Robert or Dick or, Bert or Rob or Bob, or, there's, so, and I thought, oh, this would probably look quite nice as a graph. So especially if there's overlap between the nicknames, when it's not clear, basically, that one nickname can kind of refer to multiple real names, and
Oh
then
yeah.
how do you actually resolve that as well? And so I thought that could be a fun topic as such. And I mean, usually we looked at data sets from Kaggle or other data sources, but then I thought, I mean, we've been doing so much with LLMs and Gen AI in the last few months, all of us, and I thought that would be actually a nice use of GPT and the OpenAI API to generate just this list of nicknames, right? So I also looked for some nickname data as well. So there's also some nickname data available, which we could use to augment our list.
Cool.
But I found it quite interesting, and I wanted to share how I generated this example data set. And I think that's a good use of an creative AI usage, basically, of getting some word knowledge out of GPT and ChatGPT, so that we can basically show how to generate example data and then how to load it into Neo4j into a graph, and then perhaps run some fun queries or visualizations on it, and then perhaps augment the data with some real nickname data as well,
Yeah.
if you want to, and if you got that time.
Sounds
As
good.
such.
And then obviously anybody that watches in chat can obviously tell us their nickname, and then we can
You can look it up,
incorporate it.
or look it up and
And,
check
and,
for
and,
it,
and,
right?
and at
So
least look it up exactly and work with it. Before we do that, though,
last week,
exactly, call for papers ends on 30th of June, which is this Friday. So you have, including today, 5 more days to submit
yes,
your submissions for the open call for papers. So anything goes. We have received a good amount of submissions already, but still, would be nice to get even more, and obviously to hear from you, hear your stories, have your presentations, be it a lightning talk or a full-fledged presentation or a workshop, if you want to train people on some specific topic that is dear to your heart, and you think, okay, people should know more about this, and you are the expert of it, and you want to give a little hands-on session, then that's also fine. And yeah, learn something about graphs, did something cool with graphs, explored something with graphs,
have a
had
cool
some
tool,
exactly.
exactly, things like that, right? So just share some kind of technical topic, right? So we're not looking for fluff, high level talks, but more for, here's something useful for you to learn and to use tomorrow, basically, right? So and so if you have something like this, please share and submit, and then we can consider your talks as well for the conference. And as you already said, sometimes you don't have to have the talk completely fleshed out and already. So if you have a good abstract and good idea what you want to talk about and a good title, then that's good enough to get started with the CFP. And then we take it from there.
We take it from there, and then there's a couple of months until you have to give a proper, fully worded abstract. So I think, that's good. It takes a little bit stress away, and there's July and August. Usually, it's a little bit quieter in most parts of the world. Can take that time and think about what you want to do exactly and how it's supposed to be.
Yeah,
but it should give us
together and so on.
It should give us a good idea of what we can expect in your description.
Exactly.
Yeah. And if you don't want to submit,
but you want to register and
you can already register. The page is also open. I'll post a link in chat to where you can find everything around it, to our page, and then you can do that. And as Ashwa asks, we have the option open that you submit a little video that is also showcasing what you want to do. So if you rather write only 1 or 2 lines of abstract, but give a short 60-second, really just brief summary of what you want to talk about, and maybe have a couple of pictures, maybe showcase something with an application, then you can do that. You can upload that, but you don't have to. So this is completely optional.
It's optional.
If you feel like a video is more than words, then add the video. If you feel like this is not needed, then you don't have to do that.
If you want to make the case for your talk. Like last year, we had actually some people submitting videos, and it was really good for some of the content to understand more of what they wanted to show, right? So it was not that obvious from the abstract, and so it was really nice to be able to watch the video and see, that's what they actually want to show and talk about. And then we could make a better decision in terms of selecting talks. Cool.
But I think I'll go through this one more time. So as Michael said, we go a little bit in a summer break after this episode. The July episodes will happen with recaps. So I'll pick a couple of best of episodes. But we will be taking a break, and then we'll see with that. But
we should for July 4th we can do Hamilton or something like that. The Hamilton
exactly
one.
We can. I'll think about this. But next week probably Hamilton could be a good one, and then we have a couple of other ones I have already in my mind that were very popular, and we will rerun. So what we do in this episode, I think you know this by now, but if you're new watching it for the first time, we will pick a data set. We will look into today a little bit different. So not really, we don't really pick a data set, but we generate something together and add that into AuraDB, or Graph Database as a Service, and then we think about a little bit how to model that. What could the model look like? What kind of questions and queries we could ask of that, and what would be a good way of navigating that in terms of visualization, maybe a little bit in Bloom, depending on our timing today. And what is Neo4j AuraDB free? It's the free edition of AuraDB, which is the Graph Database as a Service, as I said, of Neo4j. So it's completely maintained and managed by Neo4j, so you don't have to worry about anything. You just subscribe to it if you want to have the professional enterprise tiers, or you just register if you want the free tier and get going, and you get a instance of Neo4j in the cloud, which you can use for whatever you want to use it for. It's completely free, and it stays as long as you like it. It'll go, it pauses if you don't use it, so you can always come back to your dashboard and restart it, but it will be going into a sort of hibernation mode if you're not using it for a while. You get 200,000
But it's really
nice.
Sorry. It's really nice if you want to build an application that you want to show to others, or if you want to share a database with someone else, then you can put it up in the cloud and give the connection details to someone else, or you run your application against it. And as long as the application keeps running and engaging with the database, it keeps also it's not paused. So that's actually a nice way to put up demos and other things in the cloud as well.
Yeah, exactly. It's a good use case. And the limitation isn't super harsh. So 200,000 nodes, 400,000 relationships. So Michael and I, throughout this series, we have tried lots and lots of different database data sets and imported the data into an Aura free instance. And we had to cut it down sometimes a little bit, but most of the times it kind of worked with an initial scope. And I think that's what the goal is of AuraDB free. Your initial scope will be met, and if you then go further, want to do
expand,
more, then you can upgrade, and the upgrade path is also relatively easy. You just switch, and you get Bloom browser and data importer is the new workspace interface as well for you. So that makes it super easy. You can stay in one tab of your browser. You do it all from there, and you can get from a. We showed this before. I mean, today is a little bit different, as we said, but basically you can go without writing one line of Cypher, one line of code from a CSV file into a graph visualization with AuraDB free we do it in an hour. You might take a little bit longer because you're not Michael, but it'll it'll be roughly that, an afternoon, I think,
exactly.
and then you can get there.
And you can also follow along with one of our episodes, right?
Exactly.
If there's a data set you're interested in, you can basically code along, pause the video, and do something, try it out, and then continue from there as well. Right?
And in all the videos, we have a little description with some links and with some more explanation. And some of these had separate blog articles that Michael fleshed out with all the code examples. So that's everything is there.
And GitHub repository.
And the GitHub repository has the rest of it. So if you want to try anything on any of the past episodes and want to do it yourself, you're invited to do so. And
super.
Yeah, I think with that we are good to go. As always, this is live, and we encourage you to ask questions to get to us through the chat. And obviously, if you watch this on record, then afterwards would be nice to hear your comments. Follow and subscribe to the YouTube channel, which is the main baseline of the video content platform.
And there's lots of other video content also coming out from the team and in general. So it's definitely worthwhile staying in touch.
Yep.
Super. And Alex already spoke about AuraDB free, and here you can see basically the create Aura instance screen. It changed a little bit over time. So now kind of the create free instance is one single card here, and professional instances are here on the side. And so we can basically just say, okay, this is kind of our limits, and what can we do? And it's paused after 3 days of inactivity, and it's running on GCP, and I can just say create free instance, and then I get the instance created. I can download the credentials into a text file, and that gives me then access to the credentials. And so it starts creating this instance here, and I can already rename it to nicknames. And while it's spinning up the instance, we can look at the generation of the nicknames, right? So what I did sometime last week is basically I just went to ChatGPT 4 and said, hey, I want to have nicknames, right? So I said basically, lots of names and nicknames, and please generate me a list of nicknames. And what's really important with these LLMs and also ChatGPT is to give it really clear instructions, right? So basically, task is to output all popular nicknames for names starting with a letter. Only answer in a comma-separate list format, no explanation, no apologies, or additional information. Actually, it turned out, at least the one that I used from Python, GPT 3.5, still apologized. And then I had to clean up the files because there were some letters like Q and X and so, where there are no real names and nicknames. So it's basically the first thing it did is basically apologizing and explaining why there are none. And so I actually had to go through this, and sometimes it also kind of just made up nicknames. So that's kind of the hallucination part where it very, very confidently tells you something. So it generates content, but it's actually ridiculous made up stuff, right? So I basically also removed some of those as well, so you can see them in a second.
Yeah, and then look at those. I think that might be funny.
Exactly. So and then I told it as well. The first entry in this comma separate list is the original name. The remaining entries are the popular nicknames for this name. Right. So kind of, I don't want to have super rare nicknames. I want to have the popular ones. And I gave it also an example, like Elizabeth. You have Liz, Lizzie, Beth, Peggy, Ellie, Liesel, Lisbeth, and so on. Right. So there's lots of. Elizabeth is one of those names which has like hundreds of nicknames, basically. Right.
Yeah.
And so these are all the system messages where I tell the system what to do. And then I'm the user and say, give me the nickname list for the 50 names starting with E. And then it goes ahead and starts generating this, right? So you have Edward, Ed, Eddie, Ted, Teddy, Ned. So this is already like, how do you get from Ned to Edward, right? So it's really far.
That is
away,
difficult,
right? So it's not something that you can see just with a text editing distance or something like that, right? So it's really something where you need to have this source data unconnected, right? Or Edna to Nettie, or I mean, we already looked at Elizabeth, which is kind of like, Betsy and Betty and so on, right? So and there's also something like Evan with just Eve then, right? Or Ezra here, right? And so you see, or Benny to Espen, or Russ to Erasmus, right? So it's kind of contained somehow, but it's it's a little bit hard to spot. As such. Also, that it made up an E here for Evan. I'm not sure. It's probably done in slang or something like that, but it's really hard to differentiate friends if they all have just one letter nicknames.
Yeah. I mean, that could be something more like an inside joke thing where you talk only first letter of your name to a bunch of people.
Exactly. Exactly.
But
what happens if you get a second person?
E2.
So, but that's kind of the format that I wanted to get, right?
Yeah.
And so, of course, this is ChatGPT in the chat interface, but of course, you want to see the data in an API and you want to write it to files and use it from a file, right? So what I did next is I wrote a little Python script that basically just looks at the models that are available and then basically does the same thing that we had right now, but as an API call, right? So basically we said, say we want to have a chat completion with this model. So unfortunately, we don't have access to ChatGPT 4, but only GPT 3.5. That's why it's also making more stuff up. I set temperature to 0. Temperature is kind of controlling how creative it gets, right? So if you have the default is temperature 1, where it's basically making up stuff just willy-nilly, and temperature 0 should actually be more grounded in reality, but of course it's not 100%, right? And then you have these messages where you have this kind of role playing, right? So in this chat completion, it's actually kind of funny. You can actually do the back and forth role play between two characters, right? So for instance, if you have something like a dialogue or something between two characters, then you can basically put the two roles into the messages and they talk to each other. The assistant and the user, basically, right? So they talk to each other, and then the next thing that it completes is basically what's the next answer from the assistant, basically, right? And so what I did here is basically this text here is very similar to the one that we just saw. Basically, I just added 2 example lines and then had also some things that said, okay, I changed it a little bit where I said, generate as many lines as the user tells you to generate, and use as many nicknames as are realistic or are really in use, right? That are frequently in use. Because in my first attempt, it misunderstood it and it just generated 50 nicknames for one single name. Basically, it just had one single line with like one name and then 50 nicknames, which are then all made up. Right? So, and I basically go over the list from A to C, or A to Z, and characters, and then for each of them, I basically sent this. In principle, you could have one chat and then just add to it and take one step after the other. But especially GPT 3.5 sometimes forgets the system messages, and then you can't rely that it still remembers it. So I basically just used as if there were like
not a big deal.
26 chats basically going in, right? And then what it also shows you when you get a response, kind of how many tokens it took. It also took a while, so it took like 20 minutes or so to generate all of this because it kind of does the typical, incremental generation as well. And GPT 3.5 is also not so fast. I mean, it's faster than 4, but so, and then I just opened a file with nicknames underscore character.txt and wrote the response content into that file and close the file, right? So if we look at, let's see, for instance, nicknames, let's see, a.txt, right?
Yep.
So you see kind of all these nicknames. So you have Alexander, for instance, in the second line, Alexander, Alex, Alexander, Lex, Sandy, Sender, Ender, L, Axel, right? So that's kind of the ones, the popular ones in
I
English,
recognize
at
a
least.
couple.
Right. So and you have like lots of interesting ones. There are some weird ones, like Archie goes all the way to Archibaldus and Archibaldus, and so that's probably then the Latin form or the Spanish forms or something like that, right? Archibaldos. There were some other ones that were kind of interesting. Let me remember, like in the Q one, kind of you get the
it's a short one, yeah. Well,
apology, right? So also we told it not to apologize, right?
Yeah.
And then which is kind of pointless, and the same is I think for X as well.
Names with
As
X.
well, and I think for was it for Z? Yeah, for Z it also, that's something I would need to change in the system message next time, to omit lines that have no nicknames, basically, right? So it has a bunch of lines that have no nicknames at all, right? So and then it's kind of not even a nickname for Zelda, right? So it's kind of really poor. And there was one, was it with K, that really made up a lot of, you see also there's a lot of repetition, so it's like all the same stuff time and again. So it's kind of a little bit weird, the K one, right? So it's always Christy, Kristen, and so even for Christopher, it's Christy and Christy and Crispy. So the K one, I think, is a little bit weird. So you see that you can't trust it 100%, but I found it kind of interesting how far you get in terms of like generation. So I think we are probably at 70-80% truth here, and then you would have to clean up your data from there. Right? So what I did is I took all these files and put them into one single larger file, so we can import in one go. And what I actually changed is I replaced the first comma here after the first name with a colon, so that we can basically use this as two columns, the first column with the real name and the second column with all the nicknames. And then we split up the second column. Otherwise, the problem is that you have, for loading CSV, if you have different numbers of columns in a CSV, then the CSV loading usually gets mixed up as such, which is not so helpful. Right? Exactly. So as I mentioned, there are also some nickname databases that we could look at. So there's here one Python package that does it. And here we also found one which has like a CSV file, name to nickname CSV. And here also have the same format, kind of, right? But you also see that GitHub complains that it has different numbers of columns per row. So it can't render it as a CSV as such, right? But that could be something that we can pull in later. As such. So what I did is here I created just a public GitHub guest that we can use. I can also paste it into chat, I think. And so we can access this from Neo4j with load CSV, and then we can take it from there, right? So meanwhile, our Aura instance should have started. Yes, it's running, and we can open it with workspace, and I just take my password from the file and connect. And this time we'll not use let's see, we are not using the data modeling and import tool because the format is not a pure CSV. So we could do it, but it's kind of a little bit weird. So what I thought we would do in that, instead I just draw out a very simple model, which basically says name and nickname, basically and then we can call this also known as or something like that, right? Or whatever we want to call this, right?
Yeah. Also
Or
nice.
called or something like that. That's probably
AKA. Yeah.
Right. So or AKA, exactly. So something like this, right? So and then we could basically say the nickname one. If we also get it as a name, then we can actually add name and nickname as two labels here, right? So that it would have nickname and name as two labels. Then because some names are also nicknames at the same time.
Exactly. Yeah, I was just wanted to say, if you take the Alexander example, there was Axel. Axel is a name in itself.
Yeah, it's a regular name. Yeah, exactly. So, okay, so that's kind of the model. And so what we want to do is kind of to see if we can access our file here. So currently database is empty, nothing is in here. So we can access our file with load CSV. We don't have a header this time. From, and then we just take our raw URL here. One. And paste it in here. So let's see if this works. If not, then we need to use the underlying raw URL as row return row limit 5, right?
Yeah.
So it creates an array here out of the lines, and we see that actually I just realized I could have probably even not needed to split it out, because it seems that the Neo4j CSV loader does not care how many elements are in a row. So it seems to take whatever is there. Okay, so then perhaps we could actually save this bit. We'll do it anyway, so you also learn something about load CSV, right? So right now we get
left it and decided that
and then use it.
entry.
Yeah, exactly. Yeah, exactly. But let me show you something that's actually quite neat, because you can control what's the field terminator, right? So right now it uses comma as the default field terminator, right? So on each comma it splits it up. But we can also say field terminator, one word, colon, and then we get two entries, right? So one for the first word, and then one for all the remaining words as such, right?
Yeah.
So, and that's what we're going to use for now. And then if you want to, we can also do the one with the comma at the beginning. But so this is, now we get basically the first name. This is kind of row of 0 as name, right? We can probably do a trim around it. Should be 2 lowercase always, but just to be sure, we can do 2 lower case. Oh, no, it's actually just 2 lower. This is our name. And then the rest is basically we take row.1, it's our nicknames, right? The second entry here.
Yep.
And we just want to split this by comma. We split this by comma. And then for each of these elements, we do the same, basically trim and to lower, right? So we just say n in this list of comma separated names, we do the same, basically to lower trim of each. So we remove all spaces and we make sure that it's basically lowercase, right?
Yeah. So trim is removing the spaces.
Trim is removing the spaces, and to lower
around
exactly, and to lower makes it lowercase. Just to be sure, right?
Yeah.
So and then we call this as nicknames. And so which gives us our main name and our list of nicknames with all the spaces removed and so on, right? So that's kind of our input for the graph creation, right? So what do we need now? We want to actually create a new node. So instead of return, I turn this into with. So we want to create a new node. We said it's called name, our node, right? And it has, what do you call it? Do you want to call it name or text or name?
The individual
property.
name.
Is it name.name, or do we want to call it name.text or name. Any?
Maybe should we call it call name or something? So to make a difference between nickname.
Yeah, that's what I wanted to do with the label here.
Yeah.
Right?
I see.
So let's just call it name.name, right? So, or whatever. Right? So and this would create one node for each name entry here, right? So that's already good. So and then the other thing that we wanted to do is basically say we want to also for each of the nicknames, right? So for each of them here, we also want to create a node. So we just say unwind nicknames as nickname. And then for each nickname, we also create a node here, right? So we say just nickname and nickname here. Right?
Yeah.
So, and actually, it's interesting. So let me do something different. So originally, I remember when I said if a nickname is used as a name, we want to make sure that it's results in the same node as such, right?
Mm-hmm.
So so the problem is if I create these names here with a name label, right? Then that's fine. But if I create these as with the nickname label, this is actually a nickname. With the nickname label, then if there's already a name node with the same name, then it wouldn't be like merged into one. It would be two separate ones, right? So one with name Alex or Axel, and the other one would be nickname Axel, right?
Yeah.
So what I thought we can probably do, we call them both name, and then for this one we set something like real name, or what do you want to call them? Like what's the given name also?
Given name, yeah, given name, yeah.
Given. And then here, down here, we set an comma, a colon nick, right? So that's kind of the nickname.
Yeah, okay.
Right?
Yeah.
Should we call it nick or nickname? I don't know. Nickname, perhaps. Right?
You can call me Nick is fine, I think.
Given name or given. Yeah. Or let's call it nick, and then we can say basically nick colon name, and then it looks really good. Nice.
Yeah. Yeah.
And so that means they both will be name nodes, and then some of them will have the given label additionally, and some will have the nick label additionally, and some will have both, right? So because they're both the nickname and the real name, right?
Yeah.
Okay, so that's kind of step number one, to create the nodes, and now we would have a graph full of lonely nodes as such.
Exactly. We get all the
actually, we can try this out, right? So if you want to, we can actually try this and run this, and I hope unwind nicknames as we need an star. So sometimes Cypher wants to have like this. What happened to my star here? So it goes ahead and creates these. Let's see if they all fit into the memory for our creation, but actually they should, right? So so it basically creates the name nodes, the nickname nodes, and created 4,200 nodes in total.
Yeah.
Right?
Yeah.
So if you look into this, so we now see given, name, and nick. So if you look at these are like a bunch of given ones. Some have like the name as well, and they're all purple because they overlap as such, right? So some of them are, this one, for instance, is given, name, and nick because it's Anna, right? So Anna is both a nickname for Annabelle, and it's a name also for Anna itself, right? Or herself. Okay, so that creates these lonely nodes, and of course that's not a graph, that's just a lot of orphan nodes. And now what we can do is basically we say
we need the relationship.
The relationship where we say name is called, we said, right? It's called nickname. So we create a relationship from this node with the given name to the nickname.
Yeah.
Such, right? So this should be now, if you run this again, because merge is actually quite nice because it's idempotent. So if I run something twice with merge, then it will not create new data, but it will just use the data that's already in the graph. It's a little bit slow because we didn't create a constraint or index for the name. So that's something that we can do actually. We can say create constraint name if not exists for n.name require n.name is unique. Let's see if okay. Now created constraints, and it created 5,300 relationships as well. Right. So the constraint is also nice because it doesn't just create the uniqueness constraint, which kind of avoids duplicates, but it also at the same time creates an index. So if I search now for something, it's also much faster. I mean, on this really small data set, it's not such a big difference, but it's usually a good practice also to put this in as well.
Yes.
Right. So for instance, if I now want to say, let me find name Alexander, return n, then I find my Alexander node here, really big. And then I can double click on it, hopefully, or expand. And then I see all these
and we see what we wanted to see. Exactly. All the other nicknames and the
Alex
full
and Alexander
name.
and so on. And then from Alex, you could say, is there another nickname for Alex, like Alexis, right?
Yeah,
so Alex is also a joint nickname between Alexis and Alexander, right? So because they're all, or for instance, if I look at Alexis, Alex are joint nicknames, right? And for Axel is also a regular name, so it has its own set of nicknames, including Axel with KS, right?
Yeah.
Axelrod, Axelina, Axelius.
Axelrod is
called
good.
Axel X. Yeah, right. So Axeli and so on. So for instance, Axelrod, I think, is also a common US name, I think. No? Or a last name actually. But Axel could be a first name as well, right? So perhaps in some, right? So and so we can basically look at the graph as such, right? So what we can do now is we can look at this data a little bit more in a structured way. So for instance, we can say here in our perspective, which we could probably just recreate. Like let's delete the old perspective and create a new one. Generate should be pretty quick. So you see it only has the nick category here, right? So if I want to add also given, then I can basically differentiate between given and nicknames and then use that as such, right? And what I can then say is I want to see all the given names and their nicknames, right? Or I want to see all the given names that have other given names as nicknames, right? So, and if I run this over the whole graph, then I see a lot of these clusters, right? So because, of course, there's a certain, you know, 1 or 2 hops away that you can look at names and nicknames. Actually, let me just make sure that the text here is name. It should not show on hover. It should show it. I just hadn't zoomed in enough. Right.
Or you can make the size a little bit bigger if you want to.
Yep.
The text size, I meant.
Sorry. Let's do this.
The top.
Text size. But then it's so perhaps like this, right?
Helps a little. Yeah.
Yeah. Right. So you see these kind of clusters of names that kind of go together, right? So where different given names are basically nicknames for another name, right? And so you have these clusters, Wendell and Wendy, Fanny, Francis, Francie, Franklin. That's kind of another cluster. And actually, I hadn't expected that. That's actually pretty cool that we see these kind of clusters of names.
Yeah.
What do we have?
I didn't think there would be that many that are kind of
connected. Dwight. Yeah. Or up here we have Bryn and all the. And these are all given names, right? So which is really interesting. What I don't know here, you see some of them where I don't know if it actually just made up stuff, right? So so I'm not too deep into.
I'm not so sure. I mean, I guess it's
Bryn related names.
Yeah, exactly.
It looks a little bit like just continued.
Yeah. If they are indeed that widespread, also is the other problem. How many?
But this one is also interesting, right? So you have Gabriel to Gabe to Briley to Brielle, and then Brielle is also Gabriella, which is an Ella, and then you get to Emily and Elizabeth and so on, right? So and Elaine and Elena and Lena and so on, right? Evelyn. So it's kind of an interesting thing where you could say I want to see Evelyn, for instance, and like Gabriel, right? So how are Evelyn and Gabriel connected? So I can actually dismiss all the other nodes. So I have only Gabriel and Evelyn remaining here. Let me just remove this so that you actually see them. Right, here are 2 nodes. You can actually also move them side by side a little bit, and then zoom in, right? And so we can actually select them both and say what's the shortest path between Evelyn and Gabriel, right? So, and actually this time in the shortest path it just goes over all the relationships and all the nodes, and so it goes through Gabi, which is actually my mom's name. Her name was Gabriele, and she was only called Gabi. And so it's so you can connect names, right? And then we can also say if you pick another name, let's say
Tedder just says in chat is aka metamorphosis. Is like exactly you have a
exactly
you have a weird nickname, and then if everyone explain why it is, then you can pull out your graph and say, well, actually, it comes from Gabriel, which is Gabby, which is Gabriella, which is Ella, so that's why I'm called Emily.
Exactly. Right. So I, for instance, I was always called Michael because we had so many Michaels in my class at school, like 5 or so, and everyone had their own. Like one was called Michael, one Misha, one Michael, one Mike, one. We had basically covered all the nicknames because we had to differentiate the people as such, right? So here we have Michael, right? And you see Mick and Mickey and Mikhail and Mike and Misha.
Michelangelo, all right.
That's Michelangelo, right? So, right? And then this other spelling, which is more prevalent in Slavic languages as well, right? And then
there's also Mitch, a typo.
Right? No, I think that's actually in Slavic languages and Michal as well, right? So and so that's kind of interesting to see how they are connected. And then we can basically say, is there a connection actually between Michael and Gabriel or something like that, right? So we can say, is there a shortest path between the two? And it seems there is one, right? So you can basically go from Michael to Michelle to Shell to Michelle to Rachel to Ray to Israel to Issy, Isabel, Bella, Gabriela to Ella to Gabriel, right? Somewhere here. So it's there's interesting connections.
Use the graph database to come up with your name.
Exactly.
Find a link between Gabriele and Michael.
Exactly. Oh, that's a good idea, right? So you can basically find a link between your parents' name and your own name. But if you're not Alexander III or something like that. Right. But the other thing that's also interesting is kind of if you look at these visualizations. So here there are like force graphs, but of course these names. Alex, it kind of reminds me a little bit of what we did with the etymology last time, where you have these derived words, like one comes from the next, right? So, and it's kind of similar to this.
It's
and so what you can do is actually do this hierarchical layout where you basically see it as in a hierarchy, right? So how are things basically structured over multiple levels, right? And if I expand this one, for instance, then the hierarchy changes, for instance, right? And then I get basically other different ones, right? And then I can expand again, and I get another level of name and nicknames, basically, right? And then I have Michelissimo, which is then the Spanish version of Mitch or Mitchell, right? But you also see here, I'm not sure if they're like then made up ones again, right? So if you scroll in here a little bit, so I'm not sure if the Italians have so many versions, but it could be, right? Especially as nicknames, right? So because nicknames don't have to adhere to anything, right? So that I found this really interesting. But something else spotted my eye when we looked at the data here at the beginning, which is kind of the shared nicknames or shared names, right? So I wondered which kind of names have like the most shared nicknames between them. So that means if we spell this out as a pattern, right? So we start here from the left side and say we find a name and one name, which is basically going to nickname. That's our nickname, right? And then from the other side, there's another name, N2. Here it's a given. I want to use this here. It's a given name, right? And this is a path, right? So if I just use this as a path and return, let's say, return path limit 20, it should show us more of these kind of overlap things, right?
Yeah.
So you see kind of these overlaps here, right? So where here's 2 overlap, here's actually 3 overlaps, right?
Yep.
Here is actually 4 overlaps between the names, right?
Three different names. Yeah. Given,
Oh, yeah.
just remember, given are the purple nodes, and the nicknames are the.
Yeah, but these two given have actually 4 that they get
These
shared,
two,
right?
yeah, true, you're right. And then this other one is also in there.
Yeah, if I remove this one,
yes.
so you see the 4,
Okay.
right?
Yeah.
And so on. So that's kind of the path as such, right? And if you return more than 20, let's say we return 100 or so, then we might see interesting other shapes pop up here. But what I wanted to know is kind of which of these pairs, N1 and N2, are actually most frequent, right? And what are their nicknames? So I just say, give me the 2. We probably don't want to have AB and BA, so I just say where ID N1 is less than ID N2. We also don't want to have the same name showing up with itself, so we say less than, and so it basically filters out half of the matches from N1 and N2.
Yeah.
If you use this. And then we count them, and we can collect distinct, let's say, nn dot name, right?
Yeah. So we count the individual, well, not the individual, but we count the relation
here, right?
the relationships between the nodes.
And then we just can say with these, where you can say order by frequency descending, and let's say we get the top 25 or top 50 or something like that, right? And we just return n1.name, n2.name, frequency, and nicknames, right? So these would be our top overlapping names that share most nicknames, right? So we see that Marietta and Marin share a lot of nicknames, including Masha and Marie and Mariah and Ria, for instance. So the M names, the Christopher one, I'm not 100% sure because that's kind of this made-up one, and also that's kind of, they are really close to each other as well, right? So you probably want to exclude the spelling there as well, right? And or here as well, right? So they're very close. So what I wanted to see is there like some other names that are not the same that I actually have. So here were some of these kind of that looked very generated, like, can you see these Bryn Leda and Bryn Lea and Bryn Lei? And so I think that those might not be correct. Yeah, most of them have, they're very close already, right? So I wonder if you can actually use our epoch library to see what's the edit distance between those such, right? So there's a function in epoch, call epoch.help distance. And there's an epoch text distance function. It compares two strings and gives us the Levenstein edit distance. So that's a number between 0 and 1 to 3. So you can basically, or there's other ones like Hamming distance as well, and Yarrow-Winkler distance and so on and so on, right? So, but if you use, let's say, return epoch text distance between Alex and Axel, right? So that's how many edits do you have to do to get from Alex to Axel, right? So that's actually 2, right? So because you have to probably switch a bunch of, right? But for instance, if I go from Alex to Alexa, only 1, right? So because it just adds 1 character here, right? So we could say we only want to see nodes in our data here where the distance between n1.name and n2.name, n1.name and n2.name is greater than 2 perhaps or so, that we have really more different names.
Different, yeah.
Right. So, and we can actually also output the distance here at the end, right? So we can just say as distance. Or let me put the nicknames last so that you can still see the distance.
And there was a question from Eshwa on the if it is okay if we have twice N1 and 2 given. It's yeah, that's totally fine, and we defined in the second line where it says ID N1 equals not equals ID N2 or is less than ID N2. By that we made sure that not the same name is picked up again, but in the pattern it's totally fine to come back to the same label of a node again.
Yeah, exactly. So because that's a good point. If you had not done this, then N1 and N2 could even be the same node, right? So because if you have one node that's called one nickname, and then this nickname, oh no, actually there's only one relationship between one node and one nickname. So it's probably wouldn't work that it comes back to the same name because there's only one relationship between the two. But the pair of N1 and N2, we want to have only Axel Alex and not Alex Axel, right? So we want to have only one of the, because they are kind of equivalent, right?
True. Yeah.
So you can see all the M names are still very prevalent.
Yeah.
As you can see here, right? And what we can do is probably add another condition here where let's see.
Do you want to go funky and say the first letter must be different?
Yeah, we can also say this, right? And basically a substring of n1.name, 0, 1, which is the first letter, is not the same than input name. All right?
Yeah. See if there's something.
So there's like the
it got me again. But Margaret and Peggy, that's a good one.
Exactly, that's a good one, right? So because that's kind of Maggie and Margaret and Margareta, and so my daughter is actually called
Marge.
Her second name is exactly his second name is Margareta, and sometimes you can call her like Maggie or Peggy or something like that, right? So yeah, Margaret and Peggy is a really interesting one. Marjorie, Peggy,
Gavin and
Christina,
Vincent.
Don,
at
Gordon.
The top of your list now. Gavin and Vincent.
Here, Gavin and Vincent. That's interesting that they have shared nicknames. Interesting.
Comes via Vin, maybe.
Donald and Gordon comes from the Don part, right?
Don, yeah.
Kevin and Vincent as well. Geoffrey, Jeff. Felix and Philip, that's also a little bit surprising.
Oh, wow,
right? So
okay, yeah.
I hadn't thought that's kind of interesting, right? Isaac and Yvonne.
That's probably not going to work.
That's probably something that's wrong there, right?
I don't think
I think there might be a wrong line break in the file that I messed up to add. Cool. And so you can continue to explore this and basically see how close is someone. So for instance, if you find some, imagine you find
at the bottom of it is another good one, the Frederick and Winfried, which you wouldn't think of in the first place, but obviously comes via the Freddy.
But they have the same stem here, right? So what I wanted to say is, if you want to now disambiguate entities, right, and you say I have like two entities, one is kind of Rob, and two is name like Dick, then is there an relationship between them, right? So do they have basically say n has some relationship like one hop, or so to n2 return, or you could even express this as where clause where exists this relationship between the two, right? Where there's one relationship between the two, then you could say 1 and 2 are connected, and then it could where exists. I just need to spell it correctly. So this doesn't have anything, right? So because there's kind of one hop in between that's missing, right? So we have Rob to robot and Dick to robot. So we could also say up to 2 hops apart, right? And then it still doesn't show us anything. So that's surprising. Actually,
Is it even in
perhaps
there?
you want to look at n, n2. Oh no, some we Dick. Oh, I could imagine that Dick is missing because that kind of
Yeah.
didn't go through the GPT filter.
Yeah.
So, but you could say Bob, for instance, right? So, and then hopefully Bob is actually, yeah, Rob and Bob. There is a relationship between them, right? So there's probably not in one hop. Oops, sorry, didn't want to do this. Probably not like in zero direct relationship, but you can say up to 2, and then there's a relationship between the 2, right? And then
Yeah.
if you want to use this not as an exists, but as an additional match, you can also do this match here and create a path and return a path. Then this shows you basically how Bob and Rob are connected, right? And then you can say, are they connected more than once? And then the strength is higher or something like that. And then you can create a confidence score, for instance. If there are more than one connection or so, then you can have a higher confidence score also. And then you create a relationship between them and say similar also, right? And then, you can go from there. And you can basically then create a similarity relationship graph on top of the nickname graph, right? Okay, and before we go, I just wanted to see if we can actually get the second one here imported.
Yeah. Let's give
It
it a
has
try.
first name, nickname variations, right? So we can basically say load CSV with headers from URL. Oops. From URL as row, return row limit 5. And so we get our nickname variations and our first name, right?
Yeah.
And then we would basically do the same as we've done before. Let me just find our, it should. Oh no, now it reloaded. I didn't want to reload. Control R. Anyway, so should I lose the history? Oh, that's not so good. So what I can do now is basically, as we had before, create a node, the name node, name follower. We say again row dot. This is first name, last name, and row dot backticks nickname variations as nicknames. And then we say with name, comma, n in follower. This. N in split nicknames, comma. We do follower trim of n. And then we can create our 2 nodes. Our name here and our name. Unwind nicknames as nickname. To type quickly because and then create a relationship basically n called nn, and then we also had the set nn nick, and here we had set nn dot given, right? And then there was I think a with star somewhere in here. And so it created another 349 nodes and a bunch of relationships, but not as many as are in the file because in the end our it's 460 in the 63 in the file, so our existing data already covered some of that as well, right?
Yeah.
So and now we can go back and see if we have any graph, and now it's there, right? So and then we should have also if X pointers, it should go to
show.
Yes, exactly. I mean, it's an official.
Yeah.
It comes from Richard, right? So that's kind of the rich.
Yeah.
It's kind of a translation, word translation to this, right? So and then
Yeah.
you basically have the other ones from Richard as well. Richie, Rick, Dicky, right? So and then
Yeah.
Ricky, right? So and then so that's where it comes from.
Yeah.
Right? So we can see, we can also pull in other data sources and then augment the data that we get from the LLM as well.
Yeah.
Cool.
This-
I think
just
that was
add some more
all things that we
next.
wanted to show today. And we also had time. So
Perfect.
really, this was a fun data set and fun
Fun data set,
exploration.
exactly. Combining a couple of tools, existing CSV files, data importer, and ChatGPT, and some APOC
OpenAI APIs, and
APIs,
Yeah.
APOC APIs, exactly, and combining it all to a fun little nickname graph. So if you ever wondered why Michael is called Michael, because his mother was Gabriele, and there's a direct connection between Gabriele and Michael.
Exactly. They drew this little graph on the wall, and then.
And if you want to try it
good one.
yourself, have a go at it. I guess you'll put some information in the GitHub
in the repository at least,
repo over the next few days. If you want to play with other data sets, you have a history of the whole playlist on YouTube. So pick something that you're interested in and go there. Other than that, I think we are good. As I said, on Monday next week, I'll play a replay, a best of. So no live interaction on that date. And then on Wednesday, 5th of July, if you're not a US citizen and have day off, then I'll have a live stream with Maria Di Maro from the University of Naples about a conflict search graph, which was her PhD thesis on that matter. So I think that will be interesting, and that's happening on the Wednesday. And with that, I think
super. Thank
you.
you.
Thank you for watching. Thank you
Yeah.
For participating, and see you soon. Thank you, Michael.
Take care, everyone.
Take care.
Bye.
Bye.